Hello everyone, welcome back to the workshop. It's a beautiful, quiet Monday out here, and today we're going to be taking a look at a new project. Now I needed a new project like I need a hole in my head. I've got the Astro I need to work on, the big flatbed truck. I've got my pickup right there I need to work on, that crate in the back over there that's filled with electrical plugs that I need to disassemble and store, and everything just needs cleaned. But I've had this idea in my head for almost half a decade, a little over half a decade, as a matter of fact, and I just had to put it into steel. So, this here is the beginnings of an electro-pneumatic forging hammer, or just a power hammer. If you don't know what that is, look up Anyang 33-pound hammer. That's Anyang 33-pound hammer. And that's kind of what I'm copying as far as the size goes and the mechanisms and all that. The style and mechanisms, all of that, have been around for well over 100 years. It's it's the same style that any power hammer manufacturer used, except for two of them, Pilkington and All Days and Onions. Now the difference is, if you don't know, if it sounds like gibberish, this here's my ram. This here moves up and down. This is what forges my material. This is what moves material. This is what does all of the work as far as hitting my workpiece for doing forging and blacksmithing and closed die forging, open die forging, etc. This here moves up and down, hits the workpiece. Now to move this up and down, I put it in this sealed cylinder. There's a seal down here. This is sealed, that's sealed. Everything in here is sealed. So this can move up and down, but it requires air pressure to move it up and down. Now to create the air pressure and the volume that I need to move this up and down, I have a compressor cylinder. Now this cylinder has a compressor rod in it. That is, again, sealed here, it's all sealed. Now to get the air from the compressor over to my hammer, top, ram, whatever you would like to call it, I have air channels, or I will drill air channels through. Now I don't want this hammer, it'll be drilled through at the bottom and the top, by the way. Now I don't want this hammer to be running flat out, just balls to the wall all day. I need to be able to control it. I need to be able to tap things very softly. I need it to return the ram up and keep it in the up position whenever I am repositioning top tools at the bottom, doing things like that. So, to control all that, I will have what are called rotary valves. So if you look up here, right now I have an air channel milled through. I will drill a hole in the top or the bottom, I haven't decided yet, for the exhaust gases, all of the air pressure that is not going to be used to do work with my ram. And that relationship between what air goes to the ram and what air just gets exhausted is controlled by a rotary valve that's just drill and bore a precise hole, put a chunk of round stock in there with a very, very precise fit, and you mill slots in it so that it works similarly to a three-way valve. You can modify that valve, you can change it. If you find you want more airflow, less airflow, you could put a new one in there. That's why I'm going with a whole machine design, is so I can modify it. But I'm going to drill and bore a hole there, go through. There's going to be one up top, one on the bottom. You might think I don't have enough material here. You know, up here I have nice thick forklift tine. This is forklift tine, by the way. This, and this. But these two would be bolted together to form enough material there to put a rotary valve in. Now, what I should have done if I had designed this hammer for a rotary valve in the top and the bottom is do the same thing, get another chunk of plate, put two plates at the bottom. But when I first started building this hammer and first started designing it, this was going to be that weird Pilkington style that is unlike what anyone else used. So this hammer uses air pressure on the bottom of my compressor cylinder, shoves it on over, pushes it up, and then whenever the hammer is up and you want to bring it down, well, not when you want to, just whenever the crank goes up and pushes the compressor cylinder up, creates pressure in the top, moves it on over through my valving, brings the hammer down, does the work. The cycle repeats. It brings it back up whenever the compressor cylinder goes down. Then whenever this guy goes down, this guy's going up. The original plan was to make this solid 3¼ inches, which is the bore of both of my cylinders, is 3¼ inches. I was going to make it solid 3¼ inch, and it was going to be a Pilkington style, where on the return stroke, instead of having pressure go down through more seals, more rotary valves, more seals over here with a very precise guide, the vacuum, a check valve would close and a vacuum would draw this back up. And that was my original idea. I wasn't going to have this long of a ram, but I was talking to Mark Krause, who is arguably the best hammer mechanic on the planet, and he said that that was a bad idea. Not because they didn't work, but because the control you get from a vacuum return Pilkington / All Days and Onions style hammer is apparently not the greatest. Now, I don't have any experience with power hammers, and frankly, to be honest, I don't care that it wouldn't have had the best control. But he made a very compelling argument, and I thought about it, and I realized that yes, having pressure to return it would be best, because my compressor cylinder would have to be much larger to create enough vacuum to return this in a timely manner. Even though it would be simpler, I would have more material into it, and the mechanism isn't as well understood as this Nazel / Bechet / Massey / Chambersburg style, where there's pressure on the top and pressure on the bottom. Every power hammer manufacturer, they use this style where there's pressure on the bottom, pressure on the top. It is more complex, but again, the control is extremely good. So that's what I decided to do. So that's where I'm at. Now, all of this stuff has been done at my day job. All of the work so far, none of it has been done here. I didn't really want to film it because I don't know how they feel about the YouTube and all that, and I really didn't want all of my coworkers flocking to my channel. Not that I'm opposed to it, but I didn't want them disappointed too much. To mount this mechanism, because this is just a mechanism, it needs the crank, it needs a frame, it needs an anvil. This here is going to be sort of my main frame. This is a chunk of I-beam. It's fairly thick, maybe 1/2 inch thick webs, which is plenty thick enough for my hammer. I'm going to cut out this middle section here, and that will slide in between, these two rails here will slide in between my hammer, and everything will be bolted together. I know that a bolted together power hammer is not the greatest design. It's not a good design, frankly, for large, powerful hammers. But I hope that for a small hammer like this, it will be adequate. If not, I can always redesign it. I can always weld things together or braze them. If these end up leaking, I can weld things together. If they end up shifting on the frame itself, I can weld these to the frame. Not that I really want to, because that would distort things, but it is an option if it comes down to it. I also have cylinder hones if I need to hone out my cylinders after welding, stuff like that. So everything right now is a very, very tight fit. Actually, I can show you guys. If I take this is cylinders and backwards, but and let it equalize. Now, if you're a real machinist, you know that that isn't super impressive, because you can do that with up to 3 thousandths worth of clearance. But as of right now, everything has 1 to 2 thousandths of clearance between this and my cylinder. I will be putting proper seals and everything. None of this is finished. The only thing that is really finished are these tubes, because there's nothing else I need to do to the tubes. Everything is getting seals. I'm probably going to order some kits for air cylinders to seal off this ram and this, or the piston, the compressor piston, and the ram itself. I thought about doing cast iron rings and felt rings and things like that, but I'm going to try to find a kit, and then I can machine these to suit whatever kit I get. So that has been this little project. I don't know what the timeline on it is. I'll try to film more of it, and I'll definitely show it off whenever it's done, because it'll be an interesting little machine when it's complete, if it runs. If it doesn't end up running, then I will change stuff until it does run. That's one reason why I wanted to bolt stuff together and make everything kind of modular, is I can always just take it apart, make a new stuffing box if this doesn't work, or modify it without taking the whole hammer apart. I can always replace the ram. If this piston doesn't end up working, I can change it out. So it'll be interesting when it's finished. But until then, thank you all for watching, liking, and subscribing, even though I am mostly absent. And have a good day.